So, for day 3, you get to learn exactly 2 new things. Okay? 2 new things. You get to learn about angle of elevation and angle of depression. And some of you are going to really feel that, you're going to feel some solidarity with the angle of depression, welcome to my world. Okay? But, don't forget the angle of elevation matters too. Okay? All this is looking up and looking down.
Side to side.
No, just up and down. And see, angle of elevation is when you look up. I know, because it's elevated. An angle of depression is when you look down because you're depressed and don't want to look people in the eye. Okay, whatever helps you remember it. Okay? But, and it's a pretty big but, the most important thing here is that both of these angles have to be measured with a horizontal line. You got to have a horizontal line. Now, as I look out across the room here, is there a horizontal line I could draw from my eyeballs?
Yeah.
There is. Can you see it?
No.
No, but if you had Photoshop, could you put it in?
Yes.
Yes, you could. That's going to be the key to solving all of these problems, is being able to find what is my horizontal line, and then for angle of elevation, you will go up from that horizontal line to get an angle. And for angle of depression, you will go down from that horizontal line to make an angle. Can you remember what horizontal is?
Yes.
Remember it has horizon in it? So it's like the horizon, it goes side to side? Yeah. Okay? If you can do that, that's your whole lesson. Ta-da!
Done. Alright, we're doing flips.
Now, what I want to do is I want to show you some different ways this is going to get used. So you can practice drawing pretty pictures, setting stuff up. Some of them we will solve, some of them we're just going to set up. Somebody in my last class had the gall to use the E word, and they had to do one of these whole ones by themselves in front of the whole class.
That seems like a thing Reese would do.
So don't be that person. Instead, for this first problem, draw the picture that you think goes with this problem. Now, if I'm looking for an angle of elevation, what's something I'm going to have? A horizontal.
Well, yeah.
What's going to be the horizontal in this problem?
The ground.
The ground. The ground is going to be horizontal. And what's going to be vertical?
The ladder.
Which is it, the wall or the ladder?
The ladder.
We typically build walls up and down, and then the ladder is leaning against the wall. And oh look, it's a right triangle. So I can use Pythagorean theorem, special rights, and or trig.
But how's it
What?
how's it a right angle?
Because we build walls straight up and down, and ground is usually level. And for these problems, we assume that. Just like in physics, you assume cows are spheres, Now, what numbers go where here? 8 is at the bottom because we're 8 feet from the base of the building.
And X is X.
20-foot ladder, so my ladder is 20 feet long. What's it asking for?
The angle.
Ooh! Now for angle of elevation, you need a horizontal and look up. So where's my horizontal I'm looking up from? The ground is my horizontal. I'm going to look up. So I'm looking up the ladder. So what is the ladder's angle of elevation? So that's the reference angle we're looking for. If you can draw the picture, then the trig you already learned finds it for you. So what trig would you set up for this guy now? let's see, I've got the hypotenuse and an adjacent.
So it'd be
So that's going to be your cosine of your theta is going to equal the 8 over the 20.
Do you simplify it?
Now, if I wanted to find the angle of elevation, if I wanted to find theta, this is day 2 stuff. How do I uncosine the theta to get just my angle? I'm going to use my inverse cosine. But if I do it to the left, you got to do it to the right. And so you go, okay, the inverse cancels out the cosine, and I'm back to just having a boring old theta. Over here, I've got, well, whatever the cosine, inverse cosine of 8/20 is. Well, I don't know what that is. Now what do I do? Ask your best friend. And so how much is my theta?
66.42.
And it goes on forever. So you look in your instructions and look for what do I round to for my angles.
The nearest degree.
What? No, the segments are the nearest tenth. The angles are nearest degree. So what's the nearest degree for this angle?
66.
66 degrees. And don't forget the degree sign. Okay? The trick to these ones is figuring out what to label where, so you set it up properly. So number 2, draw the pretty picture. Read the instructions, draw the pretty picture.
So I don't know, actually, how do we know to times it by a negative?
You're not timesing it by a negative. It's used the inverse. It's used the inverse cosine. You see how theta has been cosine? To undo cosining something, you use the inverse cosine. And that's how you write inverse cosine.
How do we know that?
Because it says cosine of theta. I mean, I cosine theta to get this fraction. That's what that says. I cosine theta to get this fraction. If I want to get just the angle alone, I'm going to have to uncosine. It's just like when you have 3x equals 9. You say, how did you know it was times by 3 down at 30? Because, oh, there's a times 3 in front of it. And you do the opposite. So you divide by 3, right? Well, here, I've got my angle that's been cosine. And so it's not multiplied by cosine, it has been cosine. So to undo that, you do the inverse. And so it'll be not sine cosine.
The angle of depression is the top of the tower.
How do we know?
Okay.
Because I have an adjacent.
That is right.
It's here. I have a hypotenuse.
Oh, you're adding it.
Hypotenuse. Right? All right, so let's see. You've got a 50-meter vertical tower. So this is probably one of those TV antennas or something. And then you've got the ground. And it's secured at the top of the tower and tied 30 meters from the base. And this is 50 meters. And it wants to have the angle of depression here. And this is where everybody screws up. What do I need to find an angle of depression? Where do I start? I need a horizontal to go down from. But it wants the angle of depression from the top. Is there a horizontal line at the top of the tower? No. Are you allowed to draw one?
Yes.
Yeah, so you go, okay, I need a horizontal here. Okay. And then my angle of depression is going to go down from there. So if I start there and go down to the cable, look where my angle is. That's your angle of depression. Okay. Now, is that inside my triangle? No. But there's a great trick for this that you learned back in Unit 3. And it's the fact that, is the ground also horizontal? And so these would be parallel. And what do parallel lines imply? What does it tell us about these alternate interior angles? They're congruent. Shh. So if I want this angle of depression up here, it's going to be congruent to this angle of elevation down there. Well, the thing is, it's not the same as this one here. This outside angle of depression will be the same as the alternate interior angle of elevation. Okay? You have to know that alternate interior thing. Okay?
How do you go over all your
Shh. So, that's why you save your notes. So let's set this one up then. If I want to find theta, could I use, if they're the same size, does it matter which one I solve? No. Ladies. Sorry. So, you could, do I have a triangle for this outside theta out here? No. You could draw one, but if you're lazy like me, you say, but this theta already has a triangle drawn. So I'm going to find this theta. Well, I know that its opposite is 50 meters, and its adjacent is 30 meters. So what trig function goes with opposite and adjacent?
I'm glad we're back on.
Tangent, thank you.
Glad we're back from our tangent.
So tangent of my theta down here will be my opposite over my adjacent. Okay, well that tells me what the tangent of theta is. Do I want the tangent of theta? No, I want theta, but it's been tangented. So I need to inverse tangent it. But if I inverse tangent the left,
Inverse tangent.
you got to inverse tangent the right. And your tangent, not your tangent, Mrs. Cerna. Those are going to cancel out, and your theta equals whatever your calculator says it is. Well, the thing is, could I simplify the fraction before I do the work?
Yes.
Yes, but since I'm not looking for this as my answer, I don't need to simplify it until the end. Okay? So I could simplify that to 5/3. You're going to get the same answer when you do the inverse tangent. Check it. Okay? And what do you get?
Oh, you would get theta is about 59 degrees.
It's about 59 degrees.
Also,
Because it's set to the nearest degree.
No.
Also, do you have a Band-Aid?
Yeah, there's a jar on my desk there by the candy that says Band-Aids on it.
Wait, hold on.
Now, if this angle is 59 degrees that we just found, that's this angle of elevation. But I want the angle of depression from the top of the tower, so how big is it?
59 degrees.
Well, remember, their alternate interiors are the same. So that guy's also 59 degrees, and that's the one I want.
So therefore you just found, and also through that you found another angle of a triangle.
Yeah. Yes?
It won't let me input that.
It won't let you inverse tangent 5/3?
Or 50/30th?
Yeah.
So let's see, you're gonna hit second in tangent, and then you do 50 divided by 30. Hit enter.
Oh, I did 50, the fraction 50 over there. And it wouldn't take it.
Yeah. Okay. All right. Setup number 3. Draw your pretty picture. We've given you a base for your pretty picture. Look at that amazing tree.
Definitely not drawing it in this thing.
We might not need to solve this one. We might just set this one up. Oh, don't die. Stay alive.
I hate that.
Don't give me more paperwork to do.
What did you do? Now.
It doesn't like it that way. Okay? So, put the parentheses at the end. Dude!
Do you grow, man?
Draw your pretty picture.
Or else.
Okay. And so we've got a point on the ground, 50 feet from the tree. The angle of elevation up to the top of the tree. Oh, the angle of elevation from where? What's my horizontal?
The ground.
The ground up to the line that gets me to the top of the tree is going to be 53 degrees. That's my theta. And it wants to know how tall be the tree.
How tall the tree?
Now this, guys, is how they used advanced technology in the 15th century to find how to navigate the world. So they would use, this is called a sextant. Unless it had more than a sixth of its circle, and then it might be a quartant. Okay? But you would look through it, and oh, guess what? This would be your line of sight. And so you'd look through it, and then some person would measure your angle on this protractor, only you had one that wasn't made of string and crab. It was actually like nice and usually made of brass. And you could measure that angle there and use it to figure out how high up the stars in the sky were. And if you know where they are in the sky, you can figure out where you are on the earth. And that's how they navigated across those giant oceans. This was something like literally not much better than this. We used these last year to actually go out and measure how tall the scoreboard was.
Nice. How tall is it?
Oh, you'll have to wait, because maybe I'll figure out a way for us to get to do that before the end of the semester. Who knows? Okay. Oh, it should be your midterm. I will keep that in mind. Thank you. So how would I set up to find x here? I will give you 20 seconds to write the equation you would use to solve this. So write the equation you would use. This is what you did at the end of your last night's homework, where you just wrote down the equation you would use.
Yes.
Set it up. You're not going to solve it, you're just going to set it up. And then I'm going to pick someone at random who really doesn't want to get called on.
I don't really want to.
I don't want to get called.
Okay, so Ben, what'd you set up? Why did you use tangent?
Because it has the opposite.
There's the opposite is the thing we're looking for. The adjacent is something we have. So if you set up the tangent of that 53, you would have x over 50, which you could solve. Now, we're not going to solve that right now because that's day one stuff. Y'all know how to do that. But it wouldn't take you long. It'd take you one step to find out how tall the dang tree is.
And
Okay? Yes?
If you did it a different way, like you could do cosine and
If you did cosine,
it would just take longer.
well, if you wanted to do cosine, you'd need the hypotenuse. Do I know the hypotenuse? Then I couldn't use cosine.
50 over angle. Like
Well,
you could make
if I wanted to do that, then I would be doing tangent of this angle.
Oh, okay.
And so I could figure out this angle and do the tangent of that angle, but that's just more work. Okay, number 4. Draw your pretty picture. We got our lighthouse here. Shining its pretty light. It's shining its lights everywhere. Yee!
that looks like a cell tower.
I know, it does not look like a lighthouse, but whatever. I want to find the distance from the boat to the foot of the lighthouse. So this is the distance I'm looking for. I know that the lighthouse is 210 feet tall. Oh, I need an angle of depression, so I need a horizontal to do an angle of elevation or depression. So am I going to depress down here? Is that the angle of depression that I want? No, it said from the top of the lighthouse. So you're standing up here, you're the lighthouse person. you've got an angle of depression going down to the boat, but where's my horizontal?
210.
Yeah, it's going to be up here. So you need to draw your horizontal and find that here's that angle of depression, which is 27 degrees. A lot of people make this inside angle be the angle of depression,
Yeah.
and that's why you always need to start with a horizontal. Either angle of elevation or angle of depression always starts with a horizontal. Okay? Shh. Now, if this angle is 27, what else do you know? Yeah? The horizontal lines are going to be parallel. And parallel lines imply that these alternate interior angles will be. So how big is this angle of elevation to the boat, from the boat to the top? It's also 27 degrees. The biggest mistake people make in angle of depression and elevation is this one up here, forgetting that horizontal at the top. Okay? You always need a horizontal to do elevation or depression. Okay? Now to set this up, you could say I'm looking for an adjacent. I have the opposite, so I could do the tangent of the 27 is 210 over x. And then you would solve that the way you learned to solve on day 1. How would you solve that? You'd have to multiply x on both sides first. That doesn't get x by itself though. Then you would have to do division from there to get whatever x equals, because those would cancel out. But I'm not going to figure that out because I'm more concerned about, can you set up the problem? You always need your horizontal to do it. And then, of course, y'all being honors and all, we say, well, what if we put 2 problems into one? Turn the page over.
Oh, God, what are we doing?
Now, this is where colors are going to be important for me. Some of you won't care, but it's going to help me. I've got a rescue team. They're down here 1,000 feet away from this cliff. Okay? So here's my little team. Here do be the cliff. Okay? And it says a climber is stranded on a ledge. So here's a little dude stranded there on a ledge. You getting the picture now?
Yes.
You see the climber up on the ledge. There he is. Okay? Now that rescue team measures the angle of elevation to the top of the cliff. So here's your horizontal, and then here's the angle of elevation to the top of the cliff. Goes right there. What is that angle of elevation? It's 70 degrees. Okay? Now the climber is just up here on the ledge. Is he up at the top yet? He's not. And so they measure the angle of elevation to that guy, and it's not as big. How big is the angle of elevation just up to the climber? It's 55 degrees. And so now I'm supposed to figure out how far he is from the top of the cliff. Yep. Well, if you don't know what to do, figure out something you can do. What's something you can do in this picture? I have the angles. What else can I find?
You can look at the other angle.
I could find the other angle. It's not going to be very helpful, but I could find these top angles. What else can I do? Y'all are honors. You have to start learning to think about what we've learned. What's something you can do?
You can just do you can like show the tangent.
Yeah, look, if I know this angle's 55 degrees, could I figure out how high up my little dude is up the cliff?
Yep.
Yeah, that's opposite, this is adjacent. So which trig function are you using? Tangent. So you could say the tangent of that 55 degree angle is going to be my opposite over adjacent. So W over 1,000. Okay. So go ahead and solve that. Y'all have your best friend with you. How high up is my climber there? You're going to have to multiply by 1,000 on both sides. And what are you going to get? It doesn't say what to round to, so I don't care what you round to. 2 or 3 places is good. I've got some people not actually typing on their calculator. Everybody gets to work the problem. 1,000 tangent 55. Okay, Mariana, did you find it yet? Or Dina? One of y'all find it? 1428? Ish?
Because we're rounding to tenths. So it has to be,
Oh, did it say to tenths?
round measures of segments to the nearest tenth.
To nearest tenths.
So it would be 0.1.
0.1.
It would be 0.2 because it's 0.15.
Oh, it's 0.15, so it would be a 2.
It's 0.14.
It's 0.148.
1.48, but we don't double round. We don't look 2 places over.
Mine rounded on the top.
Yeah, don't do the rounding automatically.
How do you take that off?
It'll be in your mode, and it'll be in your
Yes, that's a float.
yeah,
Float.
go down to where it says float.
And then, yeah.
Okay? So that tells me this amount. That tells me how high up he is. Is that what they want?
No.
They want how far is he from the top of the cliff. I know how high up he is. How do I figure out how far he is from the top? What do I need to know?
Why?
Why not? I need to know the entire height of the cliff. I need to know this whole thing. That's why. Can I find why?
Yeah.
Okay, set it up. I'm trying to find this whole height. I have color-coded what you need. I need y. I know the angle of elevation to the top of the cliff. And I know the distance, so I want you to set it up. Everybody set up how you're going to find that, because you need to practice this. You're going to have to be able to reproduce this kind of thing on your homework and on your test. Practice thinking for yourself. Don't expect everybody to spoon feed you all the time.
No.
Let's see, I need y. It's opposite of my angle. 1,000. Oh, is this another tangent?
Yes.
But what angle am I going to use here?
70.
The 70, because now I'm looking up higher. And it's going to equal y over 1,000. Yes?
When the angle isn't 90 degrees, the opposite, if it is the longest angle, it isn't a hypotenuse.
We don't ever use the 90-degree angle in trig.
So if it's, so the hypotenuse is only when it's a 90 degree angle.
The hypotenuse is, yeah, the hypotenuse is always just the hypotenuse. And we're always assuming right angles.
Okay.
Okay?
So it will never be the opposite if it's the...
No. The hypotenuse is always the hypotenuse. It's never opposite, it's never adjacent. The hypotenuse is just the hypotenuse. Good question.
Hypotenuse.
And so you're going to solve this guy just like you solved the other guy. And how high is it to the top of my cliff? 2747? 0.5? Okay. So I know how high it is to the top of the cliff. I know how high my little stranded climber fella is. Can you find how far he is from the top now?
Yes.
I want everyone to do it and write your answer down. And I want everyone to police everyone around you you and see if they actually did it. Spy on each other. Make sure they do it. I'm counting on you.
Number 6.
5. You're not done with number 5. We know how high up he is. We know how high the top of the cliff is, but we need to know how far he is from the top of the cliff. And so to find that, I'm going to need to subtract it. And so, let's see who really looks like they haven't been paying attention, or just that they really don't want to answer. Claire probably doesn't want to answer. How far is he from the top of the cliff? 1,319.2.
2.
4?
No, I got 4.
4 what? Feet. Now this should have been done backwards. I should have put the big number on top.
Yeah, I don't know.
I don't know, I don't want a negative distance, but you would still subtract them to get this. Okay? So that's how far, now, so basically, he is closer to the top than he is to the bottom, so it'd be better for them to try and get him from the top than to try and get him from the bottom. Okay? Number 6.
This is how trigonometry will save your life.
Set up the trig equation for this one, for number 6. I'm trying to fool you here, so be careful. See, the ladder, the maximum length of the ladder is 100 feet. Okay. The ladder's greatest angle of elevation possible is 70. Now, what's the angle of elevation have to be from?
The top of fire.
From a horizontal.
Well.
Is the ground my horizontal here?
No.
No, the ladder doesn't go to the ground. It goes to the top of the truck. So there's your angle of elevation, being the 70 degrees there. Okay? And so they want to know, what's the highest above the ground it can reach? Will my triangle tell me that? No. My triangle will tell me this height right here. So go ahead and find that height right there. And you'd go, okay, my angle I've got is 70. I have an opposite and the hypotenuse. Opposite and hypotenuse, that's what? Sine, no sinning. So the sine of 70 is going to equal x over 100. And when you multiply by 100 on both sides, how big is x?
100 sine 70.
93.
93 point,
94.
it'd be 94.0. Okay. If I tell you to round to the hundredths place, you have to put the hundredths place there. If I tell you to round to the tenths place, you have to put the tenths place.
All degrees are
Okay.
to a whole number.
But this is a distance, not a degrees. Okay. And so I would have this. So 94.0 feet is this distance. Is that the distance that's the highest above the ground the ladder will reach? No. This is 94. But above the ground, how am I going to figure out that whole height above the ground? Oh, if this one's 8, this one's 8. So I can add the 8 and get the full distance to be, what, 102? And then you wouldn't leave it naked? Okay. So these are going to require you to actually think occasionally. You can't just start doing junk. Yeah.
We have to put 102.0 after that, or no?
Let's see. Yeah, it says put distances in the tenths place. So yeah, we would put that. Okay? For number 7, we're not going to solve 7. I want you to label 7. Fill in your picture with what you think goes in the picture. Read the problem, fill in the picture.
These problems are equally hard to
Got some creeper in an apartment building looking all over at everybody.
So for the, it's kind of a dumb question.
No, it's not.
Anyway, so for just a regular angle, you're only trying to find you solve the SOHCAHTOA, you solve it by finding the missing, by finding the missing ones, right?
Whatever it says to find. Yeah. So for this guy, ooh, they give you an angle of elevation and an angle of depression. How fun! Okay. So let's see. And the office building is 500 feet away down here, so I bet it's 500 feet away right there as well. Do you think that would be true?
I believe that would be true, yes.
Okay. And then let's see, the angle of elevation to the top of the building is going to be 23. Is that how you labeled it? And then the angle of depression from that horizontal to the base of the building is 50 degrees. Is that how y'all labeled it?
No. I don't understand.
Well, it says you've got a dude in an apartment building, and he sights, that means he looks up to the top of the office building across the way. So he's looking up here. And it says the angle of elevation to the top of the building is 23 degrees. So this angle from the horizontal where he's standing, because remember, in order to do an angle of elevation, you need a horizontal, right?
Yeah.
So I said where he's standing is horizontal, and the angle of elevation is 23 degrees.
I didn't know it was from where he was standing. That's why I got it.
Yeah, okay, well see, I'm glad you asked then so we could clarify. And then from where he's standing in his apartment here, the angle down is 50 degrees.
No, that's his apartment.
Yeah, his apartment is right here. Yeah, and here's the office building he's looking at. So here's your office. Here's your little creeper dude looking out the window, measuring all the crap. And he's looking up, and he's looking down. So for some of these, you're going to have to use common sense to figure out what the heck is happening in the picture. Because the trig part's going to be the simple part. Setting it up is going to be the hard part.
Oh.
Now for this guy, you would be able to find out how high it is to the top of the building, and you'd be able to find out how tall it is down to the bottom. How would you find out how tall is the whole office building over here?
X plus Y.
You would have to add the two guys up. Do you guys know how to add?
No, yes.
I hope so. Okay.
Oh.
Set up the last one then. Draw your pretty picture for the last guy. My dad literally did this going fishing to figure out that he was going too fast in his boat to catch a fish.
Priorities.
I know. He's an engineer. He does things like this. So go ahead and set this one up. We assume that water always goes to level. That's why we use it in levels, is that water always is flat. And so it's got waves, but they're considered horizontal. No, this could not be the Titanic. That is not nearly far enough to be the Titanic.
So how do you know that?
Now here, they didn't draw the vertical line. But that's okay. You can draw vertical.
Oh, we need to fight. We need to fight.
Shh. So for this one, you've got an angle of depression. What do you need to write an angle of depression?
Clinical depression. Horizontal.
A horizontal. Do we have the horizontal?
Yes.
Yes, the water is your horizontal. And then we're going to depression, that means look down at a 29-degree angle.
Your kids participating in depression.
Okay? And then if I want to know how far below the surface of the water the object is, that would be this distance. And if I want to know how far must the ship travel to be directly over it, that would be this distance here. Could you solve those?
Yes.
Yeah. For the X guy, that's opposite. Oh, what piece? I don't have my adjacent. How am I going to find X?
Magic.
Oh, I have the hypotenuse. So opposite and hypotenuse is sine. So the sine of that 29-degree angle would be X over 1400. How would I find the horizontal distance he needs to travel? Yeah, that's the adjacent. So you would need cosine of the 29 would equal y over 1400 to get the y distance.
Or you could just use Pythagorean theorem.
Or once you have one, you could use Pythagorean theorem for the other. It's up to you. Okay?
I like Pythagorean.
Alrighty. Questions, problems, complaints, concerns, or comments? Okay.